Hello, everyone, and welcome to our webinar, Google Gemini Ultra Unleashed. My name is Matt Brown, and I'll be your moderator today. One of my main jobs at SingleStore is to organize these weekly AI webinars. We do 2 per week. Actually, we did 3 this week, but we demo data and AI use cases and new tools and technologies. I post about our webinars every week, so if these are topics that are interesting to you, feel free to connect with me on LinkedIn to stay in the loop. I also love to hear your feedback or ideas on topics or tools that you'd like to see in future sessions, so I hope to connect with you. And then speaking of future sessions, if you click to the next slide, you'll see that on Monday, we will be presenting how to build no-code AI chatbots using Flowise. You can come join us to learn how to use the Flowise no-code platform to integrate AI into custom-built chatbots in just a few minutes. So if this topic sounds fun to you, go ahead and RSVP right now. There's a tiny URL link on this slide. I'll put that in the chat in a few minutes. You can also take a photo or a screenshot of that QR code. It'll take you to the same place, and I hope to see you there. Back to today's topic. You are welcome to participate in the discussion throughout the session. There's a Q&A button at the bottom of your Zoom console. We have a mission to try to answer 100% of the audience questions that come in. That has become increasingly difficult over time. We have over 2,000 registrants for today. We often get hundreds of questions during the session, but again, we will answer every single one, even if that means following up with some folks via email. So ask away, make sure that you include your name and email address in the question. We will not be answering anonymous questions. If you click to the next slide, you'll see that we'd also love for you to try out the technology that we're going to be talking about today. In fact, anyone who tries it today will be entered for a chance to win the brand new, recently released AirPods Pros from Apple. All you have to do is visit that link that's on your screen. It's the tiny URL Ultra Unleashed raffle. I'll put that in the chat as well shortly. You maybe already know that SingleStore has had a free trial for many years, but in the past few weeks, we have also released a new, totally free shared tier. We'll talk about that a little bit later on, but you can get access to the full database engine capabilities of SingleStore without any payment commitments, which is pretty cool. So I'll introduce our speakers really quickly. My name is Matt Brown. I'm the head of global growth at SingleStore. As I mentioned before, I get to organize these awesome AI webinars every week to show the world what's possible with general purpose database with vector capabilities. We have upcoming webinars on OpenAI's new Sora model. If you saw that news yesterday, Ayush and I were just talking about this. We're going to do one on that. We'll do one on AI agents. We'll do one on managing LLM hallucinations. We're going to do one in, I think, like 10 days on building Gen AI apps on MySQL data. So really cool topics. Would love to see you at those webinars. Again, you can connect with me on LinkedIn if you want to get little social reminders of those. And then the real star of our show is Ayush Pai. Ayush is a computer science student at Georgia Tech. I found him online after he created some viral videos and demos of AI, which were really cool. Since then, we have partnered with him on quite a few projects where he demonstrates the power of SingleStore for AI applications and use cases. So I'm going to start off real quick. I'll give a very short overview of why SingleStore, why is it the perfect solution for real-time AI, and then I'll pass it over to Ayush for today's demo. As I mentioned, I think SingleStore is a distributed relational database system that can handle both transactions and analytics in the same engine, HTAP, for those of you who know that term. So it's been great for years to handle high power and data-intensive applications that need scale and speed. Those applications that have lots of transactions happening, lots of data, and need to make sure that latency and concurrency are handled well. You can think of, a lot of our customers. There's big banking customers that have these sorts of capabilities, software companies, insurance companies, ad tech. I mean, really, it spans a wide gamut. But it's any of those applications that need performance in milliseconds. And sometimes that's performance for the end user, handling an application. Sometimes that's real-time analytics, like in a dashboard or something like that. So that's what SingleStore has been for years. We started off as MemSQL. We became SingleStore as we became that unified single place for transactions and analytics. And then back in 2017, something else happened. One of our financial services customers really pushed us to add vector capabilities to SingleStore. They were kind of insightful and ahead of the curve in that regard. We developed that capability since then, and it's been great for AI ever since, especially in the past, year or so when this AI renaissance is happening. So if you click to the next slide, what you'll see is that at a very high level, SingleStore has MySQL compatible architecture. It can handle streaming data ingestion, analytics and transactions in the same place, multi-model capabilities. Think about JSON, time series, full text, spatial, vector data. And so, if you like Mongo's ability to handle JSON documents simply, but you don't like its speed or performance with real-time analytics, then SingleStore has an API for that. If that's interesting to you, go ahead and Google SingleStore Kai. It's a MongoDB API. No code changes, no query changes, but lightning fast analytics on JSON. We're also going to do a webinar on that soon. Or if you like the power of a data warehouse like Snowflake to handle large-scale BI analytics, but you don't like Snowflake prices or speeds, SingleStore has you covered for that too. Or if you like something like Pinecone, focus on vector indexing and similarity search for Gen AI apps, but you don't like a specialty vector database or having lots of different databases for different purposes, different applications, and you really like that speed, scale, multi-model support, SQL syntax, again, SingleStore is the better option. I might be biased, but I'm a big fan of SingleStore. And then just in the past 2 weeks, SingleStore has announced a ton of new AI capabilities. We have a new ANN indexed vector search that's 1,000 times faster than KNN or other methods. So you can do, Gen AI and vector search really at scale, super fast. It's milliseconds. We also have a new job service that can automatically execute data workflows in SQL or Python notebooks. We have a new database engine, and we have that new free shared tier that I mentioned before. So I think I've probably talked long enough. The last thing I'll mention is at the bottom of this slide, we're on AWS, GCP, and Azure. We can also do on-prem. You can run it anywhere. We can do a hybrid, a very flexible and powerful solution overall. That's SingleStore. I'll hand it over to Ayush now to take you through the fun stuff.
Awesome. Thank you, Matt, for that great introduction. So welcome everybody to today's webinar. My name again is Ayush Pai, and I'm currently a computer science student at Georgia Tech. And today we'll be exploring, the new Gemini Ultra and what it has to offer, right? Before we get into that, let's just have, like a brief introduction into like what generative AI is. Like, what is this new field that we're exploring today? What is all this buzz around, So Gen AI is kind of like a fascinating field that's really rapidly evolving, right? At the core, it's kind of involving AI systems that are able to create content across various mediums such as text, images, music, videos, and more. So this technology doesn't just replicate what it learns from like vast data sets, right? It uses the information to generate new original outputs that we've never seen before. So by analyzing these patterns, styles, and features from their training data, these AI systems can really utilize, complex neural networks algorithms to really understand and recreate data structures in novel ways. And it's not really a duplication what's going on. It's really kind of like how artists learn from their predecessors and then goes on to create their own unique works in a sense. That it kind of in the sense Google Gemini is kind of poised to be like a game changer in the space along with OpenAI. It leverages the latest advancements in neural network technologies to support the generation of content, more nuanced and sophisticated than ever, right? This is kind of like technology that we've never really seen before, especially with, if you've seen Sora that came out yesterday. We'll go a little bit into that a little bit later. But some like the multimodal capabilities of Gemini, all these text generation capabilities that we've really never seen before until this, unraveling of GPT and now Gemini. So as we progress through this webinar, we'll kind of really do like a deep dive into how Google Gemini Ultra works, its potential applications, and really embark on this journey to understand how generative AI is not just transforming the digital scape, but also like how we perceive and do creative and machine intelligence in like multiple applications, right? So diving deeper into one of the technical intricacies of generative AI, we have large language models, right? And this is kind of the basis of, everything that you see today with, really common technologies that like ChatGPT. I'm sure you've all used ChatGPT at some point. And, the whole goal of large language models, right, is to generate a coherent and contextually relevant text response from the user's query. This is really achieved through, this thing called the transformer architecture, right? This model has really revolutionized natural language processing in the last 5 years. It came out in a paper called "Attention is All You Need," 5 years ago, and the transformer is really unique because of its thing called self-attention mechanisms, which really allow the model to weigh the importance of each word in a sentence, in relation to every other word. This kind of contrasts with earlier models that really process text sequentially and miss the subtleties of language that come with non-adjacent word relationships. So in the architecture of models like Google Gemini or GPT, we really encounter a decoder-based approach. So this really means the model kind of dispenses with a separate encoding phase and instead really focuses solely on decoding, and mapping input directly to output. So it's kind of a streamlined process that enables more efficient text generation without the overhead of separate encoding processes. So that's kind of like a technical rundown of how these large language models work. Obviously, the training involves a lot of unsupervised learning on large data sets, huge data sets, right? Some of these models have billions and trillions of parameters at this point. The model learns to predict the next word in a sequence, really absorbing the complex patterns and linguistic structures without the real need for labeling training data. And enables the model to really generate responses, and feel like natural and human-like in a sense. And some examples of some of these large language models that we see today, obviously, are Gemini, which we'll go over today. We have GPT, Claude, Llama, Mistral, and there's many more. And so before we go on to directly talking about Gemini Ultra, I wanted to talk about a little bit about like diffusion models. It's another aspect of it's another aspect of this whole generative AI landscape, right? It's kind of a paradigm shift in image generation, that employs like stochastic processes that like iteratively transform random noise into detailed images, right? So you can take in literally any prompt of text and it could generate these brand new images. And this whole process is called like denoising. And it kind of is a technique where models learn to reverse the noise added up to the image over several steps. And the training of these diffusion models kind of leverages unsupervised learning as well on large data sets that allow them to predict these noise patterns and then reverse it. So essentially what it's doing here is it's applying these learned gradients from the data sets, to gradually remove the noise. And then in this process, the model gains a nuanced understanding of like how the noise is kind of distributed, which enables it to recreate it, in a sense. So that's kind of how these diffusion models work, which is another aspect of generative AI, that allows you to get images and videos as well. So a neural network obviously is at the heart of this process. It does fine tuning the image through the multiple passes, and then obviously as we get closer and closer to the high fidelity output, the model's ability to iteratively refine its predictions, is kind of like remarkable, and like it's very state of the art at this point. And some of the leading examples right now is Dolly, Stable Diffusion, Imagen by Google, and we'll kind of go over one really special one, Sora, today. So expanding on this, right, we have diffusion models that have video generation. And this kind of approach implements, diffusion across spatial and temporal dimensions that ensure, generated video sequences are not only visually coherent, frame to frame, but also maintain like smooth transitions from frame to frame as well. So the whole thing is like these models can understand and replicate, the complex interplay of movements that occur in from one frame to other, from one frame to the other, and really kind of show like how these movements are, happening in the real world. So they use these motion and continuity algorithms that really, employs like motion prediction, continuity algorithms to like maintain the natural movement. And these algorithms kind of adapt to the changes in scene, changes in action, predicts how the objects and characters will interact as the video unfolds. So some examples of this are OpenAI Sora, obviously, which came out yesterday, which is a really big deal. Also Google Video Bird. There's some other examples, Midjourney, some of these examples of these video generation. But I'm going to show you some of like my favorite ones from yesterday before we go into Google Gemini. It's kind of like a preview for, one of our future webinars once the API comes out for Sora. Um, okay. So the prompt here is the camera directly faces colorful buildings in Italy. A Dalmatian looks through the window, and this is a completely like AI generated video. It's kind of crazy to think about that it's got this good, right? And this is from OpenAI. They have a technical report as well, and it's kind of crazy how good these videos are getting. Um, so let me pull up another example. So this one's a lot more creative. So New York City submerged like Atlantis, right? Fish, sea turtles, sharks swimming through the streets of New York City. So it can do like not only like photorealistic stuff, but also like really creative prompts as well, and does a pretty good job at actually generating based on the actual prompt itself. And my personal favorite out of all that, they had hundreds of examples yesterday, but my personal favorite of all of them was this next one right here. So this one is reflections in the window of a train traveling through the Tokyo suburbs. This literally looks like someone took it on their phone, right? It does not look like this. It's a very like low quality video. It's not insanely high quality, and that's the thing about it. Like anyone could have, taken this video, and there's no way of actually knowing that this is kind of like an AI making it. Obviously, the photorealistic ones, you can maybe think about, AI can make something really cool, really photorealistic, but this looks like someone just took it on their phone, and it's like, the reflections are insanely good, and you can't really differentiate between AI at this point. So, um, be on the lookout for that Sora webinar in the future, but let's get into Google Gemini at this point. So what is Google Gemini, right? So Google Gemini emerges from DeepMind's, foray into advanced AI. DeepMind is a subsection of Google, and it really represents like a suite of these multimodal large language models. So these models are really adept at processing and generating content that spans like various forms of data. So you have text, images, eventually audio, videos as well. So it's kind of positioned as like a formidable contender to OpenAI's GPT-4. And it's really designed to push the boundaries of what's possible in AI-driven interaction and content creation. And the whole thing with these Gemini models is they're kind of built from the ground up as multimodal. So the suite currently encompasses these three distinct models that you could use today. So you have Gemini Pro 1.0, which actually released a while back, actually in December, and we did a webinar on that when that released. Gemini Pro 1.5, which is actually released yesterday. And it's really great. It's almost the capabilities of Gemini Ultra, and we'll kind of talk about that today. And then we have Gemini Ultra 1.0, which actually released a week ago. So each version is kind of fine-tuned with specific capabilities and optimizations for different purposes, and it offers like different range of functionalities for developers and researchers. Um, so just talking a little bit more about the lineup here. So they kind of strategically made these state-of-the-art models. So at the bottom, so actually the first one that was released was, Gemini Pro 1.0, and this was released December 6, 2023. This was kind of like a release as a direct competitor to OpenAI's GPT 3.5 at the time, and it was great. It was not anything incredible at the time because obviously we had GPT 4 already, which had even more benchmark standards at that point. But this subsequent version called B1.5 was actually released yesterday, and it kind of marks a significant upgrade, right, in their whole lineup. So what Gemini is trying to do here is they have their 1.0 lineup, which includes their Nano model, which is for phones. They have their Pro model, which is for everyday use cases. They have it directly on their website, and then the Ultra models for even more crazy processing. And actually, the 1.5 Pro model now actually it's a smaller model, but actually kind of compares in performance to the Ultra 1.0. Um, and it really rivals the 1.0 as I was saying. And it has optimizations that cater to, operational constraints, etc. And the capping off the lineup is obviously their Ultra, which is they only have 1.0, and they released this February 8th. And currently it's available on their website. You can use it like how you use ChatGPT. You have to get this thing called Gemini Advanced, which costs $20 a month, but they have a 2-month free trial, so I definitely recommend trying it out. So that once the API comes out, you can know like how much better this is than the actual, Pro model, etc. But let's talk a little bit about Google Bard as well, because this is kind of like how their AI journey started with how you could access these models, right? So originally it was a platform for hosting, Gemini models. Actually, before that, it had some other models that it was using, but then they started to host, Gemini Pro 1.0, and it kind of underwent like a rebranding yesterday. And going forward, it'll be known as just Gemini, right? So there's no more Google Bard. It's the transition kind of consolidates Google's AI under one name, Gemini. So this is just kind of like a clarification here, because it was a very new update from yesterday, right? And Gemini has really offered its users access to Gemini Pro 1.0 model, but now it's also accessing you can also access the Gemini Advanced, which is an iteration that really brings Gemini Ultra, which is what we're talking about today. And let's talk about Gemini Advance, right? So kind of this is all released yesterday, so this is very new and exciting news. Kind of stands as Google's newest breakthrough platform, kind of offers, unparalleled access to the Ultra 1.0 model, Google's most sophisticated and expansive AI model to date, right? It's really designed to tackle the most complex of tasks. So Gemini Advanced kind of really excels in areas requiring deep cognitive capabilities such as coding, logical reasoning, and it really has these, it's really good for these deep cognitive abilities, as I was saying. And the platform not only just stands as an engineered tool for, integrating with Google's like infrastructure with their ecosystem, it also set to like enhance, functionality of, their applications such as Gmail, Docs, like Slides, Sheets. So Google's going to use this directly within their infrastructure, but then also they're going to release the API, which any company can use and build upon with the Ultra model. So, talking a little bit more about this Gemini 1.5 model that was released yesterday. So they released the Gemini 1.5 Pro, which represents kind of a leap in the AI performance over like the 1.0. And it kind of stands on par. Um, it kind of really stands on par with the Gemini Ultra 1.0, which is kind of crazy to think about because originally they wanted to have, their Ultra to be their flagship model. But now at this point they have their 1.5 Pro, which kind of like, stands on par with the original Ultra model. It shows how like fast these models are improving, right? It can now in like handle up to 1 million tokens, which is kind of crazy to think about, right? If you think about 1 million tokens, this involves like a 1 hour long video. This involves 30,000 lines of code. This involves, documents up to 700,000 words. This is an amazing step forward. Obviously, you can look on the right, you can see this diagram, right? We have, GPT-4 Turbo, which is 128K. You have Gemini 1.0 Pro, which is only through 32K. Going from 32K to 1 million is a big step up. And they also have 10 million support for research purposes, right? So again, this is a really amazing step forward that they released yesterday. Particularly, like it's kind of considering like the techniques of the past, which is what we've been using all these, getting these huge context lengths, which was retrieval augmented generation, which we'll talk a little bit about more today, which kind of like, previously facilitated all the extension of content by pulling in all this additional data from all these documents. But now you can literally put in like 700,000 words directly into the prompt of the model. Um, and this ability to handle expanded context really internally like significantly streamlines the workflow, and kind of offers more and direct, and efficient generation and analysis of content, without having to use like documents, or RAG, right? So Gemini 1.5 kind of really epitomizes like efficiency and AI architecture. And this architecture that you're using now is kind of a combination of the transformer architecture that we talked about a little bit earlier, and this new technique called mixture of experts, MOE, right? So the transformer kind of provides like the foundational, enabling the model to handle like long range dependencies, and the MOE layer is kind of, where Gemini kind of shines here, right? So it kind of breaks the model up into, expert neural networks, which are each fine-tuned for specialized tasks, right? So upon like us receiving each input, the gaining network, which is kind of like a trainable component of the MOE, dynamically routes like all the information to the most relevant parts. And this kind of like selective activation really ensures that your neural pathways are engaged and kind of reduces computational redundancy and improves overall speed. And it allows it to scale up in terms of capacity, which we saw with, like the insanely big context length, but also like to specialize, and, give it access to a lot more complex tasks, and improved efficiency. And here's kind of like a video kind of demonstrating directly from Google released yesterday, of how this insanely big 1 million token length works, with a video. So I'll walk through this, with you guys, right? So they're uploading this video, which is a 44-minute video. Previously thought to be like really hard to do, right? Because OpenAI doesn't, and none of the OpenAI models currently take video inputs. Google didn't do it previously, I believe, or at least not this long. 44 minutes is kind of crazy. So what their prompt here is find the moment when a piece of paper is removed from the person's pocket and tell me some key information about it. Right. And obviously it's taking a little bit of time to generate this 40, 50 seconds here. But think about like it's a 44-minute video and it's analyzing it that fast. And it's able to get like the time frame of when that exactly happens. And in this video, I believe they're gonna, go to that time frame and verify it. And this is kind of showing, its ability to take in these huge context lengths, these huge like amount of tokens, because of this new, architecture that they designed. And here's another one where you're actually prompting it with an image. So what is the time code when this happened? It kind of shows like a water tower, that they drew up. It's literally just a simple drawing. And pretty quickly, it's able to come up with a timestamp that looks pretty similar to that, in the video. And sure enough, it looks pretty good, right? And this is kind of really crazy to think about because it's doing this really quickly for a 44-minute video, which is a lot of tokens, originally. And 1 million token length gives you this access, this ability to do like 1 hour videos, I said 30K lines of code, 100,000 words or 700,000 words, etc. So that's kind of how that's demonstrated there. Um, and then so we have this, right? These are kind of like the benchmarks between GPT-4, and Gemini Ultra. And as we can see, we have also, we have Gemini 1.0, and we have Gemini 1.0 Pro, and we have 1.5 Pro. And this MMLU, right, is kind of like the standard for a lot of these things. So MMLU kind of is like multiple choice questions in the 57 subjects. A lot of LLMs, if you've looked at the Hugging Face LLM rankings, it's there's a lot of rankings based on this MMLU score. So as you can see, GPT-4 recorded 86.4%, in a 5-shot. And we can see that, in 5 shots, the 1.0 Ultra got 5 shots. So it's not as accurate in 5 shots. But And the 1.5, but what we're looking at is between Ultra and 1.5 Pro, right? And 1.5 Pro is like almost at the level of 1.0 Ultra. It's only 2% off, whereas like 1.0 Pro is really far away. It's more than 12% off the accuracy on, Ultra here. So it's kind of showing how 1.0 1.5 Pro is really on the level at this point, or really close to the level of Ultra of the previous generation. And talking about previous generation, it's only like, December, right? So they've already released their 1.5 2 months, 2 or 3 months later here. So these are some of the other metrics here. And this other thing called Hello Swag is, common sense reasoning about everyday tasks. GPT-4 got 95.3%. And you can see that 1.5 Pro had 92.5%, which is actually higher than 1.0 Ultra by a good amount. So we're kind of seeing like the progression in these models. So if you want, I can send out these benchmarks, or you can access them within the papers of the respective models, but let's move on. So this is another way of comparing, the context lens here, and this is directly from the Gemini 1.5 Pro paper. They had this thing called the text haystack, which is an analysis that provides like a comparative assessment of GPT-4 and Gemini 1.5 Pro, really focusing on their ability to retrieve specific information from large values of text. And this kind of sounds like retrieval augmented generation, right? But it's really about directly from their prompts. How much are they able to retrieve? And in this context, green marks, the instances where, the model was successful in retrieving correct information. Red kind of indicates where it's failure to do so. So as you can see for the GPT-4 model, it was able to do it pretty well for, the first 128,000 tokens. But after that, it pretty much failed, right? And then for Gemini 1.5 Pro, we see that all the way from 1,000 to 1 million tokens, even 10 million tokens, right? It was able to do a really good job of like retrieving the correct documents, which is great for, the you putting in like videos, long videos, or long, you can literally put in textbooks, a lot of information directly into these models. So let's start off with exploring the Google Gemini API. So exploring the exploring like a little bit into this, right? So we have the Google AI Studio, which is kind of like the place where you can get your API key, you can run some prompts. And the Gemini API is currently available for Python. They have it for web, for JS. They have Kotlin, they have iOS. They also have REST APIs, and they have pretty much every platform they would need. So the first step, obviously, is to get the API key from the Google AI Studio. You can also use the Google Vertex AI Studio as well. um, and then here's kind of like a sample prompt. So I'm using the Gemini Pro model, but it should be pretty similar. Currently don't have access to the Gemini Pro 1.5. The reason why is because it came out yesterday, and I signed up for the waitlist. Hopefully, I should be able to access it pretty soon. And the Ultra model, obviously, they don't have an API just yet, but you can use that directly in the AI Studio. So what we see here is, the process of getting a sample output from the model. So we're specifying the Gemini Pro, and then we're doing, the prompt here, which is list 5 planets with an interesting fact for each. And then it generates a response pretty similar to any large language model. And we're doing markdown so we can, see the nice formatted bold text, numbered text, etc. So that's like a quick, simple example, and you'll have access to all this code. We have a GitHub that should be sent out, and essentially, yeah, this is a notebook where you can explore all this code. These are just some like, more examples really quickly I'll go through. So it's another example of how you can understand the safety of responses really quickly with these Gemini models. So each response that the model generates has prompt feedback that can be, accessed. So you can access it with this thing called response.prompt feedback. It's a parameter of the response, and essentially this feedback will give the assessment on, 4 different safety categories here. We have harm, explicit content. We have, hate speech, harassment, etc., dangerous content. It gives like a probability of each of those things based on the prompt, and based on that, it can, block any responses from the model itself. And you can see, how that works here. You can access these, content ratings directly with this response.prompt feedback. Exploring deeper into the API here, we have, configuring these hyperparameters. So we can, there's just something called, generation config, which these are kind of like different parameters right here, right? So candidate count, which is kind of directly sets Gemini to generate a single response here because we have one. If you set it to bigger number, I'm going to set generate multiple responses, and we have stop sequences, which is instructing the model to conclude text generation based on approaching a certain, character, right? In this case, we have, period. And we have max output tokens, which is kind of setting this to 20 here. Limits the model to generate, maximum of 20 tokens. We have top P, which is an top. It's a kind of a hyperparameter that influences the selection of the word by its probability. And setting the biases towards more probable words with a higher number here kind of balances the creativity and the coherence of the model. Top K is kind of demonstrating diversity within like the candidates of words that it generates. Temperature kind of adjusts the randomness in the generated text. And diving deeper, so this is kind of how we can access the multimodal abilities. So we have image analysis here, right? So we have, it's basically you just change the model to Gemini Pro Vision. In the future, you could use Ultra as well. But the thing is, right, you have this image right here that you would open with, you would set it with the pillow library, and you can just directly put that into the prompt itself. And it would do a pretty similar thing where you just do the same method called generate content, but then you feed in like a list of the different parameters that you want to put into your input, right? So we have, the text, right, 100 words, story from this picture, and it gave a pretty good description of this picture in the right corner here. Another kind of like explanation of like how these abilities work. So we have this thing right here, and the prompt is generate a JSON of fruits and vegetables on the table with their count present on the table, right? So we have all these, and we have them all into a format of JSON that it generated for me. That's another example of how we can do object counting and then creating files out of that. Here we have code generation, which is another really great thing about all of these models. Gemini, OpenAI. Code generation is something that large language models are really becoming more and more useful for. And in this case, we just put in the prompt, write a Java program to calculate your GPA. And that's kind of like how that goes. And here's a really cool example, though, where we're actually extending its multimodal capabilities of to actually code generation, right? So we're transforming visual elements into functional HTML and CSS code, right? So that's the inputted image on the right, which is kind of like it's kind of like telling the model, here's an image of a landing page. Please create the HTML and CSS code to replicate this website and format in a code I can copy and paste into an IDE. That's a prompt that you kind of give in. You give the image as well. So the image on the right is, on the image on the left is the image that we fed in. Image on the right is the image that is kind of like the output of the code, HTML and CSS code that it generated. And obviously, it's not great. It's not like amazing, but it kind of gets the job done in the sense that it can give you a starting point, right? It can give you a starting point. Sets up all the elements, and then all you have to do is some maybe extra styling, extra like constraints here and there to make it look a little bit better. But gets all the elements there, does a decent job, and yeah, that's kind of like demonstrating the multimodal capabilities within code generation itself. Yeah, so this is kind of what it did here. So you put in the image of the thing you want to generate. It created this code and then created this output here. So also another feature of all these multimodal models, and especially Gemini, because it's really based on their whole value prop, obviously, is the multimodal capabilities, is it really can do good optical character recognition, which stands for OCR, and which really allows it to read and interpret text within images. That's basically what it's doing here. And OCR has existed for a while in different like means, and they have like different OCR models that you can download specifically just to get text out of images. But the integration with Gemini kind of leverages the model's like advanced reasoning abilities, and kind of combines it with ability to read text with the OCR models. For instance, in this example on the right, you give it this really complicated parking rules, right? And it's kind of difficult to have an actionable actionable thing from this. If you just have like you just feed into OCR model. If you just feed into OCR model, just extract all the text from there. The really key feature of Gemini and these multimodal models, it kind of leverages the model's reasoning abilities again, and kind of makes a decision here. And the question was like, is it Monday? When can I park? And the answer was you can park after 7:30, right? So it kind of shows like how OCR's capabilities kind of demonstrates like a significant step towards like creating these AI systems that can navigate and interpret like the visual and textual world as humans do. So now we'll move on to a demonstration, right? So we're creating a RAG app with Gemini and SingleStore, and essentially the main benefit of using Gemini, right, is its vast training data set. It's trained on billions of parameters. They don't release a specific parameter count for that, but billions of parameters. And the sheer number of parameters it was trained on is like the pure value of the Gemini Ultra model that we see and that was released, right? And the whole thing is that model is very big. But then the main benefit of the Gemini Pro model is a little bit smaller, and it has like the 1 million token context length to kind of take in little books or code bases as the inputs into prompts, right? So you can achieve similar results now using Gemini model with RAG and SingleStore DB. Because obviously we can't access these APIs yet unless you have like special access. So we can actually do something pretty similar using RAG. And I kind of talked about RAG a little bit earlier, but I'll expand a little bit on it now. So RAG kind of combines the powers of like large pre-trained language models, right? With external retrieval or like search mechanisms. And it kind of, when presented with a question prompt, the RAG model kind of retrieves the set of relevant documents from the passages, and then it kind of feeds that back into the prompt. And you can see from this diagram right here, right? So you have the Q&A system, and you have the external databases. That's what we're using SingleStore for. So it retrieves the documents from there, and it's going to be doing that with some sort of vector search, KNN or cosine similarity, some sort of semantic way of taking the prompt of the user, and then turning that into a vectorized format, doing a vector search in a vector database, and then retrieving that and putting it directly back into the QA system and giving the user a response. And so that's kind of like the how RAG works here. And the whole like benefit of RAG, right, is it allows you to take documents in a very big documents, and you can have multiple documents. Obviously, you can have hundreds of thousands of documents, and this can allow you to have like that 1 million token limit without directly having it, because only these specific models have it right now. And obviously we don't have access to it. And if you're using some other models such as OpenAI, Mistral, etc., Llama 2, RAG is definitely a really good thing. So we're gonna be using RAG with this Gemini Pro model. So let's get into kind of like a code walkthrough and demo here. So let's get started. So the first thing that we'll need to do is we need to figure out what documents we're going to use, right? And personally, we're going to try it on documents that the Gemini Pro model would not know about. And Gemini Pro is kind of trained up to its last training date. It doesn't really know anything past that date. I think that date was probably when it was released around December. So I chose like a topic and a document to use that kind of is a newer topic that it would not know about already. So I chose the Super Bowl, right? The Super Bowl that happened a couple of days ago. The Super Bowl, I took in this entire Wikipedia page about the Super Bowl, and that happened on February 11th. I pasted it into a document, a TXT file, and this is going to be the document that we're going to be using here, right? And the whole idea, go through like a code walkthrough here, is so we have so what we're gonna doing first, right, is we're going to be doing our Gemini API key that we kind of went over. And the way that you would get this is going to Google AI Studio. And I can show you that if you want. It's a pretty simple process, right? Next thing you want to do is configure your SingleStore DB URL. So this kind of like represents your URL for your DB and like the DB name and etc. And so then you have, you want to load the documents directly into this RAG system. So the way you're doing this is kind of like using the LangChain API. The LangChain API is a really great tool for, chunking and, you working with text data to really format it well for these large language models, right? So the whole idea here is we, put it into this text loader and then we, load it into these documents. And we split it with a chunk size of 2000, which is the approximate amount of words per, or words or characters, whatever you use, based on, or per document here. And then we set this documents variable equal to these text splitter for these documents. And then, then the next step is to kind of like create these embeddings with OpenAI. And OpenAI is being used here because OpenAI has a really great tool for creating embeddings, which is actually, vectorizing your documents. So what you're doing here is you're using the SingleStore DB, and then you're taking your documents and then taking the embeddings that you created. So these are like the raw documents. These are the vectorized documents, and then this is the table name in SingleStore DB. And you don't need an OpenAI client. The whole thing you use here, right? So we had our Gemini API key, enabled, and so the whole thing that we're doing here is this is a kind of like a chat loop for a question and answering system. We're doing this similarity search right here in the SingleStore vector DB for this user query. That's kind of finding like the closest respond or closest kind of document to the current user's the query that they send out, and that's kind of how they find like use cosine similarity KNN to figure out like which document to use in the retrieval augmented generation process. And if it found a document, it's basically going to go and take that document as context, and then load the model here, which we kind of showed earlier, which is we're using Gemini Pro. And then we actually create the response, which is we're feeding in the user query, and then we're also feeding in the context, which is allowing it to get understanding of the context the user query with respect to the context, right? So for example, like an event that happened like a couple of days ago, it's not going to have access to that directly with its database. Or if it's a really, really long document for like a movie script or like a video, then it's not going to really be able to access that. So this is where the context comes in directly from the retrieval process. So now the next step is to run this code and kind of see how this works. And I can pull up the SingleStore customer portal. This is where you'll be able to see your like database information. So I'll go to this specific database here. Okay, while that loads, oh yeah, there we go. So we can see our databases. These are kind of the tables that we have here. I'm going to create a new table for this called Super Bowl. And we're going to run this code, right? And what it's going to be doing here is essentially it's going to be creating, first thing it's going obviously is we're creating these documents, vectorizing them and putting them in SingleStore DB. And now it's kind of prompting us to, put in our text here for our prompt. And what we're going to ask is, actually before we do this, let's try doing this. Let's try doing this without, without like the context, right? And seeing what it actually what it actually outputs. Because there's definitely gonna be a significant difference. So let's see what it does here. So let's see who is in the Super Bowl this year. And this is just using the user query and the Gemini Pro model to generate this response. Kansas City Chiefs versus Philadelphia Eagles. So that kind of shows that its interpretation of this year is based on when it was trained, because this was the Super Bowl from last year, right? So this was trained in 2023. It doesn't have access to the data that we're currently looking for from this RAG document, right? So now let's stop this, and now let's feed in the actual response. And the answer should be, if you don't know, it should be the Kansas City Chiefs and the San Francisco 49ers. So let's feed in this context and see if it's able to, get the right answer now. Before we do that, I can show you the documents that it creates directly in SingleStore. So we have your Super Bowl table here, and essentially what it's doing, it's creating the content and it's creating the vectors to create a kind of vector database here. And we can kind of see this vectorized format. It doesn't really look like much, but these are kind of documents directly here. These are generated by the OpenAI embeddings that we saw a little bit earlier. Um, so now let's ask who is in the Super Bowl. And it's able to get the right response. And yeah, that's all because of this, retrieval augmented generation. And it's kind of replicating the process of, Gemini 1.5 Pro, right? You can put in these huge documents, but for, Gemini 1.0 that we're currently using, we can only use 32,000 context length, which this whole entire document would not fit into, right? So yeah, well, I think we can start questions now, Matt.
All right, awesome. It's been a great presentation and demo so far. You're getting dozens and dozens of questions, so we will try to answer and keep the questions coming, by the way. Like I said, we're going to answer everything via email or right now. I see one from Lee at the top of my screen right now, Ayush. Have you had any limitations to the file types that you can pass into Gemini in order to leverage Gen AI?
Yeah, so currently it can only take in PDFs, it could take in images, and I believe it can take in text files and certain code formats, code files as well, with the Gemini 1.0 model. But I believe with the Gemini 1.5 Pro, you'll be able to put in video inputs as well, as we can kind of saw from that video earlier. So currently, yeah, it's restricted to those 4 or 5 things, but it's still pretty good.
Awesome. I see a question here. How good is Gemini reading handwritten documents using OCR? And I'm thinking back to some of their demo videos where they were kind of like scanning, hand drawings and writing or whatever. So I wonder, have you played with that much yourself?
Yeah, I did play a little bit around with it, and it does a decent job. It does a decent job. I kind of showed in the last, Gemini presentation I did with SingleStore. I kind of showed kind of the capabilities it has with handwritten documents, and it does a decent job. Obviously, if the handwriting is very unreadable, it's not going to be able to get some of those responses. But the example that I kind of showed in the last webinar was you fed in like a student's math homework, and it's able to, verify the answers by going through the handwritten math homework. So it does a pretty good job based on, if it's like a semi-readable handwriting.
Good stuff. Agreed. Um, let's see. Okay, so there's some questions here about, can I get the source code? Can I get your GitHub link? I'll put that in the chat now so people have it. We will also be, including this in email. Everyone will get access to the recording, and also you can have this GitHub link just for like future reference. Let's see, that answers like 10 questions. How about this one? During similarity search, how do you switch between different similarities like cosine, dot product, etc.? I know this would be maybe better suited question to somebody like Eric Hansen on our team who really focuses on our approximate nearest neighbors versus KNN. But do you feel like equipped that you can try to answer that question?
I think you definitely have the ability to change which like heuristic that you use within the single store, like, your within single store itself. You can change like which heuristic you're using. You can use KNN, you can use ANN. There's definitely a lot of capabilities that single store has. And you might know a little bit more about, some of the more like, niche ones, but definitely ANN, KNN, cosine similarity are definitely great ones already.
Good stuff. I shared this with one user's question, but I'm going to go ahead and post it here. And actually, I will also post, I think I mentioned earlier that SingleStore released Pro Max recently. And with our Pro Max, we now do both approximate nearest neighbors, which is 1,000 times faster vector search than KNN. But there's also trade-offs to that. Like in the demo that I just posted into the question, Eric Hansen compares the speed and quality of ANN versus KNN, and like, yes, ANN is a lot faster. It goes to milliseconds instead of several seconds, but there is some quality trade-offs. Thus far, the quality is still very good in approximate nearest neighbors. It's like good enough that like it's unnoticeable to the user, but there might be certain use cases where you really want the exact search or whatever. So I don't know, that might be in like math or science or something. Like you don't want kind of good, you want exact. I don't know, I'm making that up. Let's see here. Have you seen any in the chat that you really want to make sure you
Yeah,
answer? I know there's
I can answer this newest one from Jordan. So he's trying to understand the difference between GPT-4 with RAG versus Gemini Pro 1.5 with no RAG with the 1 million context length, right? The main difference obviously is kind of the way that the retrieval mechanism works. So, Gemini 1.5 Pro, it kind of, retrieves it directly from these documents from an outside source, then incorporates in the response. In terms of performance, it can be subjective based on like the specific task that you're doing. Some tasks might be a lot more equipped for, RAG-based responses, such as like if you're doing something with like customer data, that's not really inbuilt into these, models directly in their training parameters. So you would have to use RAG. But if you're doing something, where you're trying to have like a general ability, and really have like a really high context length, then I think, something where you have this 1 million parameter context type, will you give you a lot more abilities. So it depends on like which use case you're going for, but like in terms of like how they work, it's basically the retrieval mechanism. Like RAG is based on like getting these documents from an external database using vector search. And then, Gemini Pro with their 1 million context length is getting it directly from the prompt. And that's kind of like I talked about a little bit earlier with I believe the needle in the haystack, the text haystack kind of thing. It's able to get it pretty accurately from the 1 million tokens input, and then generate a response pretty well from. And that's kind of like the key benefit of like the 1 million tokens that you have there.
good stuff. I see one from Edward here. Does Gemini learn from my documents if I am dealing with confidential information? I know that's one we get on whenever we do OpenAI a lot. You want to answer that, Ayush?
So is the question, does Gemini learn from the documents? Okay.
Yeah, exactly. Is
Um,
this like private or is Google training on your data, basically?
Yeah, so Google definitely might be training on your data. We don't know for sure. I know that OpenAI definitely uses, their API to train more and more data. If you want to have more of a secure type thing, you would use some sort of offline large language model and something that you could, control yourself instead of doing API calls to another company. For example, you'd use something called Llama, which is a open source large language model by Meta, but you can download it locally and you can actually, you don't have to, do API calls directly to Meta and then like they can use your data for whatever. It's all in-house if you use one of those, local LLMs that you're not really doing API calls directly for.
Awesome. Okay, I just answered one. We might be able to do one or two more. There was a question about Mongo DB, and I want to put this on. I won't just answer this. I'll also put this in the chat because this is kind of like a popular one. But basically, SingleStore has an API. We call it Mongo Kai. It's a MongoDB API. It allows you to get real-time analytics on your JSON. We've shown it. We actually put on the website, it says 100x faster analytics on MongoDB, but we've actually more often it's 1000x faster analytics. So it's really cool. And then I know there was a question, how do I do Gen AI on Mongo data? We are doing a webinar on that exact topic in like 2 weeks. I don't have a landing page for it yet, sorry, but stay tuned. It's going to be how to do Gen AI on Mongo data. No query changes, no code changes. So just stay tuned for that. Do you have time for one more question? Do you see one in the chat that you really want to answer before our AirPods winner?
Let me see. Hmm. Change them.
I see one on real-time video. Can you input real-time video? And I'm thinking of, I don't think that's possible in in Gemini, but do you know?
Real-time video. So it's not directly possible with the current API. You can do real-time video, but actually in the last Gemini webinar that we did, I kind of made like it's actually in the same GitHub if you want to access it. You can do like you can feed in frame by frame. It does like a frame, it kind of like interprets frame by frame the videos, and then like does an analysis based on that. I also did one with OpenAI where it kind of like was like a basketball thing where you can talk to a basketball game real time, right? It's not directly inbuilt into these models real time, but you can definitely like create a loop that allows you to analyze like frame by frame. And obviously, maybe not every frame because that's gonna be a lot of frames to analyze, but maybe like one every 30 frames or every second or something like that.
That's right. I saw that, and now that I think of it, it was really fast and really good. Even though it's like taking occasional screenshots, it was
Yeah.
capturing what was going on in the basketball game. All right, let's get to the AirPods winner. Before I say that, reminder, Monday, how to build no-code chatbots using Flowise. I've put that link in the chat. I hope that we will see you on Monday. It's really cool. AI chatbots in just minutes. Hope to see you there on Monday. And then the announcement you've been waiting for. Today's AirPods go to Mohammed Ayub, a lead data scientist at JP Morgan Chase. Congrats, Mohammed. If that's not you, don't give up. We're going to give out one more AirPods later today to someone who tries out Ayush's demo. So again, I put that in the chat. You can expect it in your email as well, along with a recording of this session. Thank you, Ayush, for an amazing presentation and demo as usual. And thank you to our audience for sticking with us.
All
Have
right.
a good
Thank you.
rest of your day. Bye-bye.